Okay, so now we officially start. Hello and welcome. Okay, so I don't know, some of you, I remember you could solve this problem last time, but let me just repeat this, and then I want to more or less try to finalize the rules for exponents, but I will not finish the lesson for exponents, so at least one more session we will talk together about harder problems, okay? After everything is finalized. Then officially I will end this chapter and then I will start chapter 2, but in chapter 2 I really go according to the book. I will expand the material in the book, but I will follow the book, and in the exam the expanded material will not be included. So you don't need to be worried about the hard questions. Of course, by the way, have you seen the structure of your book? Might be sometimes it's good to explain. There are 3 level problems in the book, yes? So there are 3 level problems in the book. So I am now on this page. Of course, in your book there are no page numbers, but I have already given you the links. So here we have level 1, level 2, so probably there are no level 3. Okay. There are no level 3s for this part. Okay, but there are 3 groups of exercises. Level 1, level 2, level 3, okay? Level 1 problems are actually E points in the exam. You will be given 12 E points in the exam. Level 2 problems are related to C points in the exam. You will be given 10 C points in the exam. And level 3 problems are related to A points, and you will be given 8 points. So 10, 12, 8 in total, the exams are including 30 points. Okay, I will give you the table later. I don't remember it in my head, but I know that the minimum points to pass the course is just 8 points. Yes, so it is not hard to really pass the course, but I was trying to say, if you want to get an A, I also have it in mind. For A you need to have at least 24 points, and you should have answered 5 points from the A points. 5 out of 8 and 24 out of 30. This will bring you an A. And I think it's easily accessible. Let us, yes?
Is there 30 questions? Like one question is 1 point, or is it like one question?
No, I will not give you 30 questions because usually we have to finalize the exam in our own session. I cannot ask other teachers to give me extra time unless it is a real official exam like national test or something that the school will provide the schedule for us. But except for that, I need to give you a reasonable number of questions that I can expect you to be able to solve it in your own lesson. So what we can do you remember we have 2 lessons that are 110 minutes. So I always choose one of those sessions for the exam, so that if in case you need extra time, you should have that. For example, this lesson is very short. This is just 1 hour, and the other lesson was around 90 minutes. So I think the best thing is that I will always choose one of those sessions that are 110 minutes for the exam, so that if you need more time, I will be willing to give you the time. So that is the structure that you need to follow. So I expect you actually to start solving the problems in the book when I write them on the Google Classroom. So at the end of this one, according to these new rules, the other parts of this chapter is actually being eliminated by Skolverket, so we will not go through that. Okay? And I didn't want to talk about exponents, but I think you are learning something new. Okay, not all of them you have already studied. Okay, but then when we go to chapter 2, I really follow the structure in the book. I always give you harder problems, because that would be fun if we discuss about those problems in the lesson. But when it comes to the exam, I bring the level of the questions exactly at the level of the book. But of course, some level 3 problems in the book are also a little bit hard. So if you do not practice, you will not be able to get a good grade. Yes? So that's why you need to keep up practicing. Okay. So now if you don't mind, let us go back and talk about this problem. I think you learned a lot. Actually, my impression was very positive last time. So many people start learning how to work with these kinds of problems. So if I want to compare this problem according to the level of the problem, might be this is level 5 or 6 that is absent in the book. So if you can solve such a problem, so it means that you're already above, much above the level of the book. So you can compare the problems related to exponents in the book. They are much lower level than this one. Okay? But it was not hard. So this is why I'm saying that in Sweden probably the Skolverket is underestimating you. Your ability and capability is more than what is expected in the book. And the exponent book is the hardest one, because there are three famous ones, 5000, Origo, and Exponent. I think the exercises in the Exponent are actually comparatively a little bit harder than the other exercises. So let us actually start working them. Okay. This is not the exit room door for this classroom. Yeah, you would go there, yes. Okay. So let us now talk about this one. Do you have any idea how to solve this problem? How many of you couldn't sleep before solving this problem? This is a good attitude. You shouldn't be able to sleep if you haven't solved the problem. This is the meaning of having a passion for something. So you need to develop this passion little by little. I'm not saying that develop your passion only for mathematics, but you need to have a passion to go for it, okay? Yes, how many of you couldn't sleep before solving this? Yeah, good. Yeah, that's very good. Yes, that's a very good attitude. Okay, if you solve it, you could you have actually sleep better, yes? Oh, yeah. Yeah. Yeah, good. Okay. Yeah. But by the way, and always tell me, because you know that I have my education in a different country, so it might happen that I am following something which is not really suitable for you, and if I know about it, changing myself wouldn't be hard. But the problem is that I have to know about it. So please suggest how sometimes if this is not working for you, please let me know. I am not guaranteeing that I will always change my method. No, I will start thinking about what you are saying. Might be you are right, then I can change. Okay? So please be positive in the lesson. Okay. So I don't know if some of you have solved this problem. I want to hear from one of you. Okay, Hashifa? Yes. Ah, Hafsha. Thank you very much. Yeah. Okay, so which one? Okay, that's completely good. So you learn this strategy. Okay? So the strategy is to make these boxes the same boxes, or I don't know, the same items. Okay, so which one do you prefer to do? So do you want to write everything in terms of 34, or do you want to write them in terms of 33, or which one you have chosen and why? Yes. Okay, so you want to work with 33. Okay, so I will follow you, and then if I am doing something wrong, please let me know. Okay, so you told me that you want to make everything 33. So this is already 34. You want to make it 33. So what should I do? This 3 is this 3. I pull out 1 3 to follow your strategy. Yes, so that's as simple as that. Yes, and I follow this strategy. So minus. This is already in the right form, so I don't need to change anything at all. And here, what should I do? Yes, so I would write 3. Let me write another 3 because of 9, and then let me just copy and paste. Of course, if you can do these things in your head, it is much better, but you don't need to be in hurry. So here, what happens, you will write this times this, and then what happens here, that's okay in the 4. And then what is your suggestion for the last one? 3, yes? So we can write it as 3 times 3 times 3, or 3 to power 3, yes? Now everything I think is in order, so let me just do one more step. So our strategy is to make up 3 to the power of 34, so this combination already makes me 3 to the power of 34. Oh, okay, sorry. 33. So I should write 9. Thank you very much for correcting me. 33. And then here this is okay. Yes. Here I should write 3 times 3 to the power of 33. Yes. And that's also okay. And that's also okay. But this one I can write 3 times 3 to the power of 33. Yes. So you see that that was not hard at all. So now I can call this in my head a box, because that is exactly repeating itself in all of these terms, yes? So I have 9 of these boxes, minus 10 of them, minus 1 of them is left. Minus 1 plus 3 is 2 of them. 2 plus 3 is 5 of them. And minus 5 is totally gone. And then what is left is 3 times 3 to the power of 33. So I think 2 of you answered me correctly last time before the lesson ends, yes? I think Simon and Ali, yes? You did it together. So that answer, what one of you got it 3 to the power 35, if I remember. So pardon? Okay, so you got 3 to the power 35. So you might have made a mistake somewhere, yes? Did you detect your error? Okay, but now you understand what's going on. Ah, okay. Okay, so everyone is okay with this solution? Yes or no? Okay. Now the next, so what we learned so far, we learned something, that a to the power of m times a to the power of n is equal to a to the power of m plus n. I told you that every formula in mathematics has its own soul. Actually, it's like a poem, yes? It has a deeper meaning. If you want to read the formula, this is telling you something. This tells you that if your goal is to multiply two exponentials with the same base, you write the same base and add the exponents. So that is the way that you need to interpret this formula. Okay? And then we learned that this formula is easy to prove for natural m's, but we also showed that what will happen if we have negative powers. And we realized that for both cases, this formula is correct. Yes? Okay. Now we want to go to another formula. Another formula is that what happens if I have a and b, two numbers, I want to multiply them, it becomes a number, and then I want to raise it to some power n. For the time being, let us consider n to be a natural number again. Okay? So, for example, let me start from a very simple scenario. I want to see that what can I write in front of it. Okay, this is a number raised to power 3. It means that if I ask you what is the base, can you read the base of this exponential for me? A times b, yes? So that's the exponential. Sorry, that's the base. So it means that, and this is the exponent. So it means that I can write it 3 times. I multiply this 3 times, yes? But then you know that in multiplication, it doesn't matter if you interchange them, because 2 times 3 and 3 times 2 are the same numbers. So it doesn't matter if I start interchanging them. And then it doesn't matter how I collect them. I can write them in this way. I can start multiplying a's together first, and then when it is done, I can multiply b's together, and after it is done, I can multiply the result of these two boxes. Yes? So that would be the answer. So is that understandable? This is understandable because this is the meaning of power 3. Why this is correct coming from here? I am using two important properties of multiplication. One property tells me that if I want to, I can interchange the factors without affecting the result. Another one is that I can group them any way that I like to. Of course, I can multiply this a by this b. If I want to, I can multiply this a by the last b, or if I want to, I can multiply this a by this a. So I have chosen to multiply a's together than multiply b's together, and there is a simple reason for that. Why? Because if I multiply a's together, I do not have to write it so lengthy. I can write compactly as a to the third, yes? And then times b to the 3, yes? Okay, so now this is understandable. So now look at here and here. So I can write a times b to the power of 3. I found a formula. This is not my own rule. I discovered this rule. We discovered this rule together. Do you think that if I change 3 to 4, the same kind of reasoning will work? And I get a to the 4, b to the 4. Is that understandable? So that is not something particular for 3. This can be any natural number. But a little bit of you need to be a little bit of you need to be careful a little bit for negative powers. Yes? So let us see, if I change this to negative 3, is it still true that this is the case? I hope that at least I could convince you that because this is true, we cannot guarantee this is also true. Yes? If this is true, we showed this is true, there is no guarantee that, okay, because this is true, this should also be true. We can say that this might also be true. But before showing the truth, we cannot use that. But now can you help me to show that this is also really true? So what I mean, I want you to help me. I start from the left-hand side here. And I want to convince you to convince me I can continue with legal rules and reach to the right-hand side. Okay, how can I do that? Yes, Rasmus? Is the correct name? Yes? Yes? Thank you very much. Because that's the only way we can deal with negative powers, yes? So this is the only way that I can do it. Okay, now this is a fraction. Do you have any problems with the numerator of this fraction? Yes or no? That's just 1. But can I say something for its denominator? The answer is yes. Why? Because we just really find it out, yes? So it is a to the 3 times b to the 3. Agree? But now what can I write? If I write something like this in front of it, do you agree with me or not? This one and that one are the same. Why? Because 1 times 1 is 1. This times that is exactly this. So if I write this in this form, no one can object. Okay, but then there is another name for that, even though this name is a very nice name, but it's a name. Another name for that is a to the, not 3, negative 3. And then another name for this is negative 3. So, and this is exactly the right-hand side. So you see, I started from the left-hand side, and using the mathematical rules and laws, I was able to reach to the right-hand side. Yes? And in the way, I was using this result as well. So now I hope that I didn't prove it, but the proof is like that. So I want to add one formula in this list. So this was number 1. So let me call this one number 2, okay? So what can I write in front? I can write a to the n multiplied by b to the n. As I told you, this is like a poem. How does this poem talks to you in normal language? The second formula. Someone else? So I told you that this is telling you that if you multiply two exponents, yes, sorry, two exponentials with the same base, you write the base and add the exponents. So that is the way that we read it. Of course, I summarize it in this code, in this mysterious language of mathematics, but this is the way that you have to read it. And now I want you to decipher this formula, to read it for me. It tells you what? Yes? That is exactly that. So for example, if I ask you to read me the Shakespeare, you are reading the sentence again. But if I ask you what is the, if I, for example, if English is not my native language, I don't understand the language, and I ask you to explain it, you can explain it better. That's what I'm asking you. Can you explain this formula better for me? Except that read. Yes, please. What's your name? Oscar, yes?
If you want to take a times b to the power of n, you can write it as a to the power of n times b to the power of n.
Okay, I can read better. It's a little bit better than that, but still I can read it much better. Not much better, better might be if I read it. I would say that if I want to raise a product to any power, if I want to raise any, I don't need to write a and b. Okay, do you see? I didn't read a, m, and n in my interpretation. I told you that if you want to multiply two exponentials with the same base, I didn't read a or b or m or something, yes? Here this is the same. If I want to raise a product to some power, I can raise the factors to that power individually and multiply the answers. Or something around this line. I'm not saying that this is the only way of reading it, but this is how you need to interpret it. And then I emphasize this has to be a product, because I have seen many students, when I ask them to calculate this, they naively actually do this. You might don't believe that. Even some university students sometimes accidentally do something strange like this. But do you agree with me? Because this formula is correct for the product, for the multiplication, there is no guarantee that this formula is also correct for addition. And later, exactly in the second chapter in Math 2C, we will learn that this is not indeed the case. This is wrong in general. Okay, so be careful about that. This formula only works for the time being if I have a product here. Okay, now can you read the formula from this direction for me? This tells me that if I have a product and I want to raise it to some power, raise each factor to that power and multiply them. If I want to read it the other way around, how should I read it? These are really important. Yes, Oscar? Yeah, just read it, yeah. Yeah, the poem thing, yes.
If you have two factors,
No, two exponentials.
two exponentials
Yes?
raised to the same with the same exponent,
Yeah, exactly. This is important. If I have two exponentials with the same exponent and you want to multiply them, continue.
we can write it as
You can multiply
multiply
the bases,
the bases and
put the power there. Something like that, yes? Is that understandable? So if you want to multiply two exponentials, here it is telling you if you want to multiply two exponentials with the same bases, but might be different exponents, what to do. This is telling you the other way around. If you have two exponentials with the same exponent, but probably different bases, if you are facing this situation, what to do. Is that understandable? Yes? Okay. Now, so for the other ones, we actually don't need to bother that much. So let me give you some examples. Let me see what I have provided here before. Unfortunately, I have to put the code every time. Okay. So for example, I don't know. For example, if I have 2ab to the power, so let me make it first of all. I give you a number 2 and I give you a letter a and I raise it to power 3. What can I write in front of it? Do you think that this formula is useful for such a scenario? Yes. Why? Because this is a product and I want to raise it to power 3. So do you want to answer? Yes? Yes, but I want you to understand this formula that we discovered here is applicable to this situation. Yes? Yes? The reason that I'm emphasizing on these things so much, because right now I am teaching you the concept of exponents. The topic is the exponents. So whatever I am talking, you should be able to use one of these formulas. But when your knowledge is expanding, if you forget what is happening, then you have a lot of information and then you see a problem. You yourself need to understand which formula or which topic is it, so that you can go through your brain and find the information and solve the problem. Yes? So please listen to what I am repeating. It might seem a little bit boring, but this is the way that you have to organize your brains. Yes? Yes, yes. Yeah. But those are minor things. These are that I am emphasizing are the most important things. Yes? So here, is this formula useful for this? This is the first step. Yes, because this is a product. 2 times a is also a product, and I want to raise it to some power. Here it is 3. So this formula is applicable. And then it becomes the first one to the power of 3 multiplied by the second one to the power of 3. But we usually do not leave it like this, because for 2 to the power of 3 we have a more tangible name, and that is 8. So no one writes 2 to power 3 if we can write a. And then this one we cannot do anything with that. Yes, so we have to keep it like this. So this product, this expression is equal to a to the power of 8 times 8 to the power of 3. Is that understandable? Yes. Okay, so do you think that this formula can also work if I have more than 2 numbers? Do you think if I have a times b times c to the power of n, I can write a to the n times b to the n times c to the n? Can I? Yes, so that formula is not only for the product of 2 numbers, it can also work for the product of 3 numbers. So let me give you this example. So for example, I have minus 2 a to the power, so let us keep it simple first, because you don't have that formula yet. So I want to raise it to power 4. So is this topic applicable to this formula? Yes, because I have a product. This is the product of 3 numbers and I want to raise the whole package to some power. So this formula is applicable. So how should I apply it? I need to take the first number and raise it to this power. Yes? Multiplied. I need to take this to the power. And then I need to take this to the power. But as I told you before, usually we do not emphasize on multiplication. We can just drop them, and there is a much better name for minus 2 to the power of 4, which in this case is 16. So minus 2 times minus 2 times minus 2 times minus 2. So the answer is 16a to the 4 b to the 4. Yes, so that would be the final answer to this problem. Okay, and I told you, do you remember I told you that usually this is the easiest way to go. Some harder problems needs you to go the other direction. Yes, for example, if I ask you, can you calculate this? If I ask you to calculate 2 to the power of 7 times 5 to the power of 5 without using calculator, so how can we calculate this? So let me ask you questions one by one. First of all, look at the expression that I have written here. Do you think this formula is applicable in that context? Be careful, answer me. Is this formula applicable in that context? Yes or no? Of course it is yes, but not directly. Okay? This is probably, if you know how to solve the problem, that's of course this is applicable, but not directly, yes? Because if I want to go from this direction to this direction, I need that these 2 numbers be the same. they might be different. So I do not have any problems with the difference of these two numbers, but I have problems with the difference of these two numbers because they are not the same. They have to be the same. Okay? So how can I, now that if you know, what should I do?
So you take times 2, so one of the 1 from 7
Mm?
goes away,
Mm?
that's 4, and you do the same once again.
Mm?
One of the exponents goes away, that becomes 5.
Yes,
You have
your answer is 100% correct, but I don't like it that much because you did it in two steps. Do I really need it to two in two steps?
no,
Because you took two away and then you took another two away.
yeah,
So why we did it? We can just do it in one go. Your solution, if you write it in the exam, I will give you the full mark, but that is actually I want you to learn more, okay? So instead of 2 to the power of 7, yes, so what Alice said is actually very good and very nice. He said that I need fifth power, but I have 7 here. So let me take 2 of them away. Okay, let me tell you, let me ask you some question. Which formula on the board is used so far? Yes, your name? Abdirahman. Okay, so the first one. Thank you very much. So you see, I have used here, even though this problem is the new problem, I haven't used this yet. I have used this part. Which direction? Going from this direction to that direction. I use this formula to break this into two parts. Now, as Ali said, can I apply this formula somewhere in this product? The answer is yes. On which part? On the second part. Why? Because I have two exponents with the same exponent. Two exponentials with the same exponent. So I cannot do anything with that unless I write 4. Yes? But what about this one? Can you tell me what can I write here? I can write 2 times 5 to the power of 5, and then there is a product here. But then this has been designed in a way that you can do it in your head. 2 times 5 is 10, and 10 to the power of 5. But 10 is one of those numbers you really don't need to use the calculator. You can do it in your head. So what is 10 to the power of 5? It is a 1 with how many zeros in front? 10 times 10 times 10 times 10 with 5 zeros, yes? And then multiplying 4 by such a number is very simple. It is 400,000. Yes? So we were able to calculate this without calculator. But if I wanted to calculate this one first, how much is that? First of all, if I don't remember, I have to start multiplying 2 by itself 7 times. If I do that, it becomes 128. And 5 to the power of 5. 5 times 5 is 25. Another 5 is 125. Another 5, 625. Another 5, 3125. So you see, then my problem starts again, because now I have to multiply 128 by 3125. Of course, it is not a very hard one, but it is harder than what we did here. So this, at least this simple example shows that how efficient could the rules be. Yes, even though in principle we really don't need any new rules. We can turn everything back to the original value and calculate. But now you see that how effective it was without doing that. Is that understandable? So this is the second formula in our list. I want you to push your memory a little bit hard to give me another formula that might be you have studied before about the exponents. Do you remember? So far, which operation was our concern? Multiplication. There is another operation which there is a rule for that, yes? No, those are two advanced ones now. Okay. No, just about this exponents, yes? Division, yes? So it means that, and that now how many of you can remember what is the rule of exponents for divisions? There are two rules for division as well. Yes? This is one rule corresponding to the first one. And
the same as in the second, I think.
yes, change every multiplication to division. So that's it. So here another formula is that what happens if I usually in high school and higher mathematics we do not use this symbol that frequently, okay? So I always use this line instead of division. Okay? So if I have a to the power of m divided by a to the power of n, if you remember what the formula is. If you don't remember, let us discover this a little bit. So for example, I have 2 to the power of 7 and I want to divide it 2 to the power of 3. This problem is so simple, so you can calculate this. This becomes 128, this becomes 8, and dividing is not hard. But let us try to discover a rule. 2 to the power of 7 means multiplying 2 by itself how many times? 7 times. 1, 2, 3, 4, 5, 6, 7. And 2 to the power of 3 means multiplying 2 by itself 3 times. But you learn that I can simplify factors. So you see, 3 factors of 2 are gone with 3 factors of 2. So how much is left? 4 factors of 2 are left. So I can write simply 2 to the power of 4. How do you think this 4 is related to 7 and 3? It is very simple. It's the difference between 7 and 3. So what happens here is m minus n. Yes? And then we have another formula for similar to this formula. A over b to the power of n. This is also very important. This becomes a to the n plus b to the n. Now I'm asking you again, like a poetry, yes? So just read this formula in pure English for me, in your own language. Someone else? This is important. I want you to read this. For example, let me start. If I want to divide two exponentials such that someone else? If you think that English is hard, you can say it in Swedish, but I will not understand that. Your friends can correct you. So might be this is the reason that you're hesitating. You think that if you want to say it in English, it would be problematic, yes? Yes or no? Is that the reason or not? Is that the reason or a reason? A reason, okay. But I think sooner or later you need to learn. You know that I am also not a native language, but native speaker. Your English might be even better than normal language than me. But we have to do this. We have to learn that, okay? Yes? English or Swedish? Okay, yeah, thank you. Exponents. Very nice. But if you want to give it more precisely, because if I tell you add exponents, there is a little difference between I say subtracting exponents. In adding exponents, I don't need to be careful about the order. In subtracting the exponents, I have to be careful about the order. Because 2 plus 4 and 4 plus 2 are the same numbers, so I don't need to pay attention to the order. But 2 minus 4 and 4 minus 2, are they the same numbers? No. There is a little bit difference, okay? So here I would say that if I want to divide two exponentials with the same base, I write the base and I subtract the exponent of the denominator from the exponent of the numerator. So here you need to really pay attention about the order. Okay, that's crucial. Okay, now can someone read this one for me? Yes, can someone? Yes? No, I think you mixed the left and right together a little bit. So let us try it again. So what is the name of this expression? Can you tell me? So Abdi Rahman, can you tell me yourself, what do you call this? What is A over B? A fraction. So, and what is your goal? Your goal is to raise a fraction to the n. So that's the way that you think. If I have a fraction and I want to raise it to some power, I raise the numerator to that power, raise the denominator to that power, and then divide them. Something like this. Yes, that's okay. Thank you very much for your courage. Yes, that's very important. If you do not work on your courage, you will not actually develop that. Okay, and can someone read it from right to left for me? And that would be the final word for today. I know that you are tired. Today is Friday, last time. Yes?
If you want to divide an exponential with another exponential, you can take the basis.
No, 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 not finished yet. If you want to divide an exponential by another exponential such that with the same exponent, then
Then you can divide the basis and add power.
and raise it to that exponent. Exactly. Yes, that's it. I'm not saying I want you to yourself be satisfied of your understanding, but what I'm trying to say, every mathematics formula has something to say in words in your own language. Yes, you have to learn that. Okay, thank you very much and have a nice weekend. You're welcome.